I will be discussing the problem statement valid anagram. The problem statement says given two strings s and t, return true if t is an anagram of s and false otherwise. So two strings are anagrams if they contain exactly the same characters with the exact same frequency. Just possibly in different order. To solve this efficiently, first check if the lengths are different. If yes, they cannot be anagrams. Then count how many times each character appears in the first string and subtract those counts while scanning the second string. If any character is missing or overused, return false, otherwise return true. This runs in linear time because each character is checked once. For Unicode strings like emojis, accented letters, or non-English text, we use the same logic with a hash map since Unicode characters are not limited to just 26 letters. The solution code checks whether two strings are anagrams by comparing how many times each character appears in them. First, it immediately returns false if the strings are not the same length, because anagrams must contain the same number of characters. It then creates two dictionaries, count s and count t, to store the frequency of each character in s and t. In a single loop, it increments the count of each character from s in count s and each character from t in count t. After building both frequency maps, it loops through every character in count s and checks whether its frequency matches the frequency of the same character in count t. If any character has a different count, the function returns false. If all counts match, it returns true, meaning the two strings contain exactly the same characters with the same frequencies, so t is an anagram of s. The time complexity of this solution is big of n and space complexity is big of k. So the similar patterns which are observed while solving this problem statement are: first is group anagrams, where we group words by their character frequencies, and I'm going to solve this in a question and I'm going to record the next video after solving this problem. Next is ransom note, where we can question the intuition that can we construct one string from another's characters. Permutation in string: does S2 contain permutation of S1 sliding window plus frequency. Next is find all anagrams in a string, where we again do sliding window plus frequency in an intuition. And then last one is top k frequent elements / words, where we count with hash map then rank.